Good morning, I am Srilekha, Department of Chemistry. Today I am going to talk about on the topics of TT based video on by using a silver nitrate in the formation of chloride. So the chloride is nothing but we are using as a burette solution by using the formation for argentometry method. So the name from the argentometry method is nothing but the fast moving reaction from the Ag plus and Cl minus ions. So here we have to convert the Ag plus ions and Cl minus ion from the formation to a water samples. So here I am going to take the burette solution from the silver nitrate and the pipette solution from this water sample, and the additional solutions we are going to take the potassium chromate. From this solution we are using the titration 1 and we will take the, by using the titration there is a already we have taken the burette solution with the silver nitrate, and with this pipette solution we have taken the manganese sulfate, and with this additional solution I am adding the potassium chromate into this conical flask, which in turns to the clear yellow solution. So with this clear yellow solution, the solution we have to titrate with the burette against with the pipette solution to the burette solution, and we will get the product from the reddish brown precipitate. So this is our end point. We will have to titrate with this titrations. So while using this titration, we have to use this drop by titrations. So while we are titrating with this, we will get the reddish brown precipitate formation. This is the end point when the Na plus ions will house onto the liberate and the Cl minus ion will deposit into the solution, and we will get the reddish brown precipitate. So this is the titration while using the water samples, how we are converting it to the reddish brown precipitate. So the titrations we are going to by using this, the values of titration 1 by using a 19.4, and by using the same titration we will get the following the procedures to the reddish brown precipitate. So what is the method to using this procedure?
Silver nitrate is combined with the silver nitrate is combined with sodium chloride to get the silver chloride precipitate.
Again, adding this silver nitrate, in adding indicator of potassium chromate, it will give the endpoint reddish brown.
Reddish brown. Next.
It is used for the determination of domestic purpose of water.
It is only used for in the industrial purpose and the domestic waste product from this. And by using this water samples, we have to use all other waters from the industrial waters or waste waters by using the values of pH value, whether it is a 7 or acidic or basic medium. So this is the water samples, how the acidic medium we have to check the value, whether it from the 0 to or 7 or 7 which comes to this neutral, and with the 7 to 14 it will be considered as the basic medium. So from this basic medium we have to ionize the water samples, whether it forms as a reddish brown precipitate or other the precipitate can be converted either into the solution form. We have to check the refine list, and by using this the values we have to again repeat with this titration 2, same with this the burette solution, and with the same with this the pipette solution of 20 ml of the manganese sulfate and the additional solution of the potassium chromate, and again titrate with this burette solution, we will get the same titrate value with the reddish brown precipitate. So with this two values we have to value with the titrations, whether the formula of the volume of potassium chromate we will have the volume that is 20 ml, and from the N1 value we will have the burette value of 19.4. So by using these types of values we will get the V1 N1 by V2. By using this formula we can calculate whether the N2 of normality. So what is the normality we are using in the silver nitrate, we have to check that. So by using this the formula of V1 N1 by V2, we can substitute the values by 20 ml into, and with this 19.4 readings, and divide by the values of 0.1. This is the normality we are using in this experiment. So by using this normality we can multiply by these two values and divide by 0.1, we will get the N2 values. So while using this N2 value we have to calculate by only the 20 ml. So whether we have to convert it for 100 ml or otherwise the 1 liter of the solution for the manganese sulfate, we have to convert the equivalent mass number of the 36.5. So with this the formula we have to calculate the final value into 36.5 divided by 100, and we will get the value for the final values of 100 ml or 1000 ml, or 1000 ml we are getting for 1 liter also. So this is the formula for expressing the normality of silver nitrate. So by using this the normality, we have to convert it into a equivalent mass numbers. So find this values by using this final value, we have to convert into a 60.35 divided by 1000. So by using these values, we will get the normality of N2 value also. So by using these two values, we will have the consideration of the volume of that is normality of silver nitrate and the volume of manganese sulfate we will have to identify. So by this, we are in this experiment we are going to do by the any other water samples by using as a industrial purpose or any other drinking purpose or pH purpose, we have to finally or any industrial waters or sewage waters, we have to calculate the chloride ions whichever they present in the Cl ions. So already most of the water content based on this chloride content. So how much values or we will have to titrate with this pure solution, we will get the values for how the chloride content present in this water sample. So this is the procedure to conclude with this experiments. What is the water samples, why we are using as a chloride content from this. Thank you.